Okay, well, our profound apologies for the mix-up, which we are mystified about. And anyway, thanks to all of you who, on a very busy time of the semester, took the time to come to not one but two, events right back to back. So double stacking your seminars or whatever the other one was. So thanks to all of you for coming, and it's a great pleasure to have Kaveh, soon to be Dr. Jahanshahi, right? He's a PhD student at the University of Cambridge in the UK and has been visiting here since October and going back soon at the beginning of January. So we've had a great time collaborating on research, disagreeing on practically everything, stimulating arguments. And so, it's great to share different perspectives and exchange different philosophies of model building and research, etc. So learning from each other, I hope, and certainly I am from him. So what else can we say? You have several years of real world experience with doing land use and transportation modeling, right, in New York City regional planning context. So brings a lot of experience to the doctoral level research that we'll be talking about now. So looking forward to your talk. Thank you.
Thank you very much, and certainly I learned much more from you, and it was a pleasure working in the last 4 months in the research sector. And the seminar today is on the trend-breaking influences of yield form upon travel in cities. A strange title, but what it means is basically the effects that the land use and the densification can have on travel behavior. The travel behavior means for us the car ownership, travel distance, travel time, and number of trips. So a little bit of background. The video comes up a sort of problem that because at the moment, on average, each person makes like 1,000 trips a year. The daily average travel time is just over an hour, and this hasn't changed much over the past 30 years. As you can see here, the travel time and travel distance has, travel time and number of trips has been fairly constant over time, though you will see that the travel time starts decreasing a little bit. But in aggregate, the travel distance has had a rapid increase till the late 90s. Now it's stabilizing around 7 months per trip and 6,700 months per person. That brings lots of questions that why it is. Is this trend is going to continue like that? Do we have a drop? Have we meet the sort of like the saturation car status in the UK? Well, the different system here in terms of the land itself. But to answer these questions, we have a problem of the endogeneity and the general planning problem that everything relates to everything else. So trying to isolate what are influencing different travel, the travel pattern, travel behavior is something I start then gets interested in and then start working on. So in the literature, a large number of studies have examined the influence of land use patterns on travel behavior, but that is specifically of the car use and travel distance, i.e. accessibility, but a few only work on the travel time, partly because of the lack of data. And more recent studies aim to control the endogeneity. There are a few studies by Dr. Mutarian, Kaveh, and others such as Susan Handy, who are like working on the selection effects and various other endogenities using different methodologies such as structural cohesion model, trying to isolate the effect of the land use on the transport, controlling for all other endogenities. But again, as I said, it's less on the travel time and very few outside the United States. So this, I try to address these gaps, expanding the analysis to include trip frequency and travel time, and then controlling for main interactions within one combined framework, including the interaction between socioeconomic characteristics, land use factors, and combined. So this is the like the general model framework, there are sets of socioeconomic characteristics like gender, work status, etc., which together with the land use characteristics affect the car ownership, and all of them affect the trips. Trips are separated by the three main purposes: commuting, shopping, and all other purposes combined. And we also control for the interaction between these purposes. And in this box, we include travel time, travel distance, and number of trips separately as separate models, and then we compare the results with each other. And controlling for these interactions between trips also help us to control for the concept of the travel time budget. It means that if you are doing, for instance, spending more hours commuting, you might have less hours to spend on shopping or other trips. So that's controllable. Car ownership is also something which is the model endogenous here. Lots of previous research has modeled car ownership alongside other socioeconomic factors that cause quite a few problems, because it's a high correlation normally between car ownership and other things, like household income specifically. So modeling it as an endogenous factor could fix that issue as well. The main contribution is the way that we model the land use, and there are three papers I'm going to discuss today. The difference between them is the methodology in modeling the land use in this framework. Here it's shown as the latent variable, which is explained by sets of indicators, like we use the factor analysis to derive these indicators that I will explain further in the next slides. So we have three papers. The fourth one at the moment I'm working with on that. But the first one is the land use model as a continuous latent variable. So this one that I just showed you in the previous slide, this is that one. So land use is modeled as a continuous latent variable, like one factor, which is explained by sets of indicators, which are the accessibility to public transport, both time to bus and railway station, and then something like population density, area type, and their bus frequency. So these indicators are derived through some factor analysis. So it was lots of indicators have been checked, and these all come out as the most important ones with the highest factor loadings. We pick the ones which have factor loadings of about 0.3. And so land use model as a continuous latent variable with the first paper, which captured common correlation among land use indicators and also control for self-selection effect. In a way, here by self-selection effect I mean is control for the effect of socioeconomic characteristics on the land use, as you saw in a previous slide. We didn't have that much of attitude and behavior in that time. And then car ownership, endogeneity, and travel time budget. The second paper, we used the same system, but we modeled the land use as a categorical latent variable. So instead of being something continuous, we consider land use as a set of distinctive categories of land use with different characteristics, and then we did our model between each of these classes of the land use, and then we compared them against each other. When I get to that point, I will talk more about the differences between the two. And then the third one is instead of modeling the land use as a latent variable, we did a random intercept model. It means that the intercept of our model can vary across different land use categories. Each of them adds something to the general knowledge. Especially the last one would be very helpful in like getting the idea of the scale of the self-selection effect compared to the isolated land use. The fourth working paper that I'm at the moment working on is on the quasi-longitudinal approach that if I had time, I will go through what it means. So in terms of the data, we have the advantage of having access to one of the, I guess, best national travel survey data sets in the world. It's called the Great Britain National Travel Survey, ATS. It's collected for sort of from 2002 onward, it's a nice time to look into that. I had the 2002 to 2012, the newer years upcoming, 2013, 14 is available at the moment, I guess. But this is sort of like an ongoing survey. It's a household survey designed to provide regular up-to-date data on personal travel and monitor changes in travel behavior over time. It has a nested structure like the US household travel survey. So it has the PSU, that's the residential location, then the household level, which has the household characteristics, individuals within the households, trips for each individual, stages of the trips, vehicles, and so forth. So that's sort of the nested structure of that. And then it also adopts a weighting strategy that we also benefit from that in our analysis. The household are weights for adjustment for non-responsive households because they had access to the non-responsive characteristics as well. Based on that, the NTS team developed a set of weights to adjust for that. And also there are a set of trip weights for the drop-off trips in course of the survey week because the survey is not a day survey, the travel survey is for the whole week. And at the end of the week, the people, I guess, tired and responding to the survey, etc. So you have the drop-off sometimes. And then they develop some weights for that. The way that we use these weights, for the trip weights, we multiply the trips by the trip weights to make sure that we have a representative one. And for the household weights, in all our analysis that I'm going to talk about, we have used the weighted regressions. So the households are weighted by the household weights, which we have access to. The land use indicator that we use, I just showed you on that graph, the area of population density and various accessibilities to public transport. There are socio-economic factors, and then the travel rate of the correlation, distance, time, and number of trips. So the techniques that I just talked about need to require, because we are looking into all the interactions and endogeneities in that framework, we require something that helps us in that. And we found that a structured equation model can be a good approach to take. And so we had one combined framework to analyze all these interactions. And a structured equation model is a sort of a statistical technique for testing and estimating causal relations using a combination of statistical data and qualitative causal assumptions. It means that you need to have a theory and then you test the theory. That's all it means. So it's not that it gives you, you can't just, you should have some idea of what is influencing what based on the literature reviews, etc. That I showed in the previous graph. And then you test it whether these sort of influences are significant. So SCM is a union of what we call the path analysis. The path analysis is actually a series of the regression. So this factor, like our socio-economic characteristics, which is completely exogenous to the model, affect the land use and travel patterns. So these are different regressions. And these series of regressions, simultaneous set of regressions, which will be solved simultaneously, called the path analysis. Then we have a measurement model, which is similar to the factor analysis that often talked about in the class, is actually looking into, you can reduce the dimensions on various factors into a lower number of factors, variables into a lower number of factors. In our case, we use it for the land use, as we have sets of indicators for the land use, and we use the land use factor to represent all those sets of indicators. So these are just some formulations on this simultaneous regressions effect, the latent variable which can be endogenous or exogenous. This is exogenous one, this is endogenous one because this is explained by other variables, etc. and the error terms. So this is the model as it stands. So you would see that for all of our socioeconomic characteristics, etc., we compared it with some reference case. So male compared to the female, they were mainly dummy variables. Full-time compared to part-time, 1 adult, 2+ adults, manual, skill manual, professional, and the income level. Then the correlation having no car in the household compared to having something. And the shopping, commuting, and other trips depends on whether it's distance travel or number of trips. The main things here is that all this, for this regression is the variations of the regression which are combined together. It's not all the normal regression. So for instance, in the number of trips, we are talking about the negative binomial regression, false regression. For the car ownership, it's a product model because it's a choice between having a car or not having a car. Not a choice, but it's like a 0 and 1 non-variable. So this product model has a normal distributed error term, which can be combined with the error term of the land use effect. But if it is happening to be like the number of trips here, then it would have a negative binomial error Poisson regression. So the combination of this regression and the Joule distribution of that require the simulation to be solved. And that's what we do. So the explanatory factor analysis among various accessibility and land use variables has been, as I mentioned, should be 0.3. The factor nodes above 0.3 are used. The latent variable is considered continuous for the first paper. We call it confirmatory factor analysis, but categorical for the second paper, which is we call it the latent categorical analysis. Confirmatory factor analysis mainly focus on grouping items, as we discussed. So it's reduced the dimension to a lower dimension that we call it land use. So it's a variable-centered approach. While when you are looking into the clustering, according to latent class analysis, they are more person-centered approach. So you can look into that which sort of person happen to be in which classes, and then this sort of person, which sort of behavior they have, and how different the behavior is across different classes. So I go through the first paper. The aim of this study is looking into all aspects of the travel, as I said, and then the controlling for all the endogeneity, such as car ownership, interactions among purposes, and self-selection, i.e. socioeconomic and land use factors affect each other. And as I mentioned all these things before, that technically it's a robust model because it's accounting for heterogeneity among household members. First of all, we use the cluster error term, so because the individuals are within household, we use the cluster robust error term to make sure that the household clusters are accounted for. And so in terms of the results analysis for the first one, you would see there are lots of different results comes out of this because it's lots of regression. I selected a few of them to give you the story of what the findings are. So I will walk you through that. And these are the direct effects of influences of socioeconomic profile on land use, and the second panel is the influences of socioeconomic profile and land use on car ownership. If you can remember, I talked about that chart. It has socioeconomic affecting land use, and together they affect the car ownership. So the first panel is the result of the effect of the socioeconomic on land use, and the second panel is the result of the effect of socioeconomic and land use on car ownership. So if you look at the less economically advantaged groups, such as semi or unskilled manual workers or one adult worker, this is the travel time, travel distance, and frequency that we put it next to each other, so it makes it easy to compare them against each other. So the semi and unskilled manual workers, you will see that in all over these, compared to the reference group, which is the clerical, they tend to do less travel time, less travel distance, and fewer number of trips. One adult, though, compared to the 2+ adults, do more of all of them. Sorry, this is the effect on the land use. So it means that the one adult household live in more dense area, and the semi and skilled workers, so skilled manual workers, live in less dense area. This is one of the interesting things. So skilled workers don't live necessarily compared to clerical in a high dense urbanized area. They live in a less dense area. But compared to other groups such as skilled manual or professional, they live in a denser area. When you look at the influence of socioeconomic and land use on car ownership, I highlight here the land use effect that you would see the higher densities associated with more probability of having no car. So if you live in more dense area, you are more likely to have no car. This is after controlling for what's called selection effect here and the socioeconomic effect on the land use. So it is a sort of isolated effect of the land use. But if you look at the direct influences on the commuting, there are some interesting things coming out of it. Like for one adult household, if you look at the travel distance, they travel longer distances, but the travel time is not changed much. When it doesn't have a star, it means that it's not significantly different from zero. But if you look at the unskilled manual workers, you would see that their travel distance and travel time is lower compared to the clerical. And those who have no car in the household, specifically this has made the whole differences. In terms of the travel distance, accessibility, they are living closer to the work. But in terms of the travel time, you would see 25.4 minutes longer it takes for them. So they are much less, although they are living in the dense area, it doesn't mean that they have a good mobility. And that is one of the policy things that we can grab from these. So those households with no car, although they live in a more dense urban areas, as we found out in the previous sets of results I showed you, they have a lower distance, 4 miles in average per week, shorter distance to their workplace, but they spend 25 minutes in average per week more on that travel due to what it can be still not sufficient public transport system in place for the long walking distance. So apart from the direct effects, we had set of indirect effects in the structure equation modeling because, for instance, the socioeconomic characteristics affect car ownership, the car ownership affect the travel, so we can say socioeconomic characteristics apart from the direct effect on the travel, indirectly through car ownership it affects on the travel as well. And these indirect effects can change the whole picture,